Activity 2.1 is called Need Input, and it's all about different input devices that you can code in order to find out how the different sensors work. So I'm going to walk you through right now what Activity 2.1 looks like and what the expectation is for you. As always, the essential questions are good to write down. These are questions that you should be able to answer by the end of the activity. Now you're going to see some repeats that you've done before. However, you may have a different look at it after going through Activity 2.1. Materials, there are a ton of materials. I do not have this this device image sheet. You don't need to worry about that once you get down to it. Everything else you will find in the back of the classroom. First part, it's going to take you through what is an input. It's information or signals put into a computer system. So it's basically taking, they show you button A and button B are forms of input. When I push the button, something happens on the screen. A keyboard, when I push a key, it's going to do something. My mouse, when I click my mouse, it's going to do something on my screen. So that's where you get an input. It's putting information into the device that you're using. It can be a cell phone, it can be, there's a lot of input devices. Again, I don't have the image sheet for you, so just skip right over that. Complete the following exercise, and we'll talk a little bit about this as we go, but here's the basic breakdown for this. You'll look at the microbit. There's pin 0, pin 1, pin 2, 3V, and ground. So when you start to code in lesson 2.1, pay really close attention to what you hook up your alligator's clips to. If you're telling the code to be based off of pin 1, but you hook it up to pin 0, it will not work. So pay close attention to that. Here's the three main sensors we're going to come across. The first one is called a flex sensor. This is something where it bends a little bit, and then you're going to get a different reading. You can see one of these in like a car, for like a car alarm, or maybe it shuts off your lights. There's a lot of different ways that where it's connected to something and then it springs back open and then something else happens. Number 2 is a photocell resistor, and this is based off of light, the amount of light or the light level that you see. The most common one would be automatic headlights or a motion light based off of something as far as the light level changing, and then you can have the message display something different. Number 3 is the pressure sensor. This is my favorite one I just actually picked up not too long ago from a student, was the car seat or your seat in the front of your car. If a child weighs not enough, there will be a message that says like your seatbelt is off, or the airbag is off right now. When there's enough pressure applied to the seat, then that message goes away and the airbag is activated. So this is a very familiar thing for a car. And you can see all three of these have connections to vehicles. It's going to go through, make sure you drag and do the different activities they tell you about. Image, the input device image, the name and what it detects. You can just write that quickly in your notes. It shouldn't take you very long at all. Next big section is going to take you through pair programming. Hopefully you have a partner that you've been working with. If you don't have a partner you've been working with, this might be a great time to find a partner that you're going to work 50-50 partnership on. Take the time to watch the videos even if you don't have a partner. Hopefully when you get into high school you will be working more with pair programming and working with another partner. A couple quick videos, just a little information there. What are you taking away from that? Programming inputs. Now this is going to be where you're going to go back to the Blink message project that you created for 1.5, and it's just going to say modify the code so that when you press A, the scrolling message appears. And then you'll notice when press button B, the animation appears. The whole purpose of this is to just get you used to different inputs, and this again is an input right here. It takes you through and it's going to tell you what to name it as. Last name, that would be if you have a partner and you're working on one device. Light sensor. The microbit has a light sensor built in right there, and you're going to come across some very important numbers or values. For instance, this one is going to say it's going to have a range of 0 to 255. And that'll be important because you're going to set the code to do different things based off the amount of light that is traveling through. Conditional statements, we've talked a lot about those. This is going to show you if the light level reads 128 or less, the animation appears. So it's going to do two different things based on the amount or the light level that it's receiving. This takes you through and it shows you what should happen, what we want it to do, and code blocks to use. I want it to run all the time. Then I need a forever loop or for a forever block. Right here, this sequence of code says it's going to go forever. So if the light level is greater than 128, it's going to then show string hello. If it's not greater than 128, it comes down here and does this. Now remember, if this is true, then this happens. If this is not true, then this happens down here. So the else is your false. And you're going to keep going down here. It's going to show you how to hook up the battery pack. It's going to show you what to do for your notes, compass and accelerometer. Make sure you take the time to watch the video. It's not very long. You do need to do step number 18, where you create rock, paper, scissors to get used to the accelerometer. And you also need to make a compass, which has the compass built into the microbit. And it's going to show you exactly what to do right there. Remember, if you're with a partner, they will show you different steps and make sure you're taking turns as far as maybe 5 minutes, maybe 10 minutes, and then switch jobs. And sometimes it does show you actually in the PLTW website. Debugging steps, which you've all come across before. If you didn't write it down last time, make sure you write that down this time. Here's your code tracing chart. And this is important when you start getting into bigger projects that require more lines of code. It's going to show you, here's what you label the compass project, here's what you label rock, paper, scissors, and so forth. There's your notebook questions and so on. Alligator clips. Here's what the alligator clip looks like. The colors do not matter. When you do wiring for like a house or a business, you have to be very careful of the colors. You can't let certain colors touch. The alligator clips, that does not matter. And then you're going to walk yourself through and just keep on going. The 0, 1, and 2 pins all have the same function. GPIO, which is the general purpose digital input output. And it shows you what that looks like. The other two large rings, 3V and G, are very different. Make sure you never hook up something from 3V to the G and D, which is the ground. It will definitely cause a short circuit, and it actually fries the microprocessor. Analog. Attaching input devices to your microbit requires the 3V pin to supply power. So you have to be aware of that. You're not going to hook 3V directly into the ground. Digital value is a 0, which means it's not pressed. 1 means it's pressed, or it has the power. It's working. There's a piece of code to do, and you're going to be able to figure this out. Again, if button A is pressed, then it shows the arrow, the down arrow. If button A is not pressed, it should show this all the time. So that's how you make that change. You don't actually test on the emulator. We have microbits. You're going to want to grab a microbit and make sure you test that out. Click on these. Here's your different sensors, and it shows you the type of data read. Here's your pressure sensor. It's going to walk you through a separate section for pressure sensor. I do not have that little black piece right there. So what you're going to do is you're going to take alligator clips, and you're going to hook it to this side, different alligator clip, hook it to that side. And right here, this means it's going to set the value to, you're going to read the pin. So pin 1 is where you're hooking your alligator clips to. Then it's going to show the number value. So whatever input device your pressure sensor you have hooked up, when you push the pressure sensor, it displays a number or a value on the microbit. So make sure you write that down. Here's some examples. These are mine. This is not going to be the exact same for you. It's just, this is what my totals were, my values were. And when you get down here, input device 0 to 1023, think of 500 as about a halfway point. So then you're going to write that down. There's your photocell resistor. Pay close attention to how you hook this up. There's a positive side, there's a negative side. You have to understand that when you get going. There's your projects. You're going to work on coding those. Here's your flex sensor. It walks you through everything you need to be able to do. Bent one direction, what's the total? Write it down, type it in. What's the bent in the opposite direction? Type that total. Straight, what's the reading on the microbit saying? Type that in right there. This will help you as well. There's some notebook questions. When you get down to step number 52, this is what I need to see. You need to present to me for 2.1. You're going to use aluminum foil and copper tape, and you're going to follow the directions right here. You do need to be able to explain what every piece of code does. Please do not tell me this one is where you hook it up. That's not what it is. Pin 0 is what's hooked up. 1 means they're connected. You're pushing them together. Or what does 1 mean? You have to understand that. And that's the end. There's some conclusion questions, and don't forget to answer your questions as well. All right, thanks.